So in these next three segments, we're going to talk about risk management. We'll introduce the big picture of risk management in this segment, and in the next two segments, we're going to walk through the process, at least to present an outline of this process of risk management. So to start off, this is the basic warning here. IEC 62304, the International Medical Software Lifecycle Standard, has this comment that's very important. It says there is no known method to guarantee 100% safety for any kind of software. What you have to do is to ask yourself what can go wrong and to come up with techniques and methods to minimize the impact of this. And we are recording in the middle of this pandemic, and we have all lived through what is effectively a giant risk management exercise. There's nothing that guarantees absolute safety. All we can do is minimize harm, and this is effectively risk management on a society scale. How would we minimize the risk to both people and society at large? Now, risk management is in part cultural, it's part natural to engineers, it's part of the culture of all engineering. We joke that when an engineer walks into a new situation, the first questions are, what could possibly go wrong here? What can I do to then make sure that it does not? And what can I do if something goes wrong, that it does not cause too much damage? That's how engineers think traditionally. And in some ways, it's similar in concept to defensive driving. Defensive driving, one description I have heard was, learn to drive as if everybody around you was drunk. And if you can do that, you will survive. So this is risk management. Now, the risk management standard is ISO 14971. You can kind of see the outline here. We started with general requirements, and then there's three very core processes: risk analysis, risk evaluation, and risk control. It talks about this concept of residual risk, review, and then post-production documentation and activities. And then there are three annexes that actually explain the standard, and these are very interesting, especially Annex A. If you get your hands on the standard, it's well worth reading. So what is risk management? ISO 14971, we just looked at before, says that it's a systematic application of management policies, procedures, and practices to the task of analyzing, evaluating, controlling, and monitoring risk. So we need a few more definitions, and we're going to spend the next 2 or 3 slides defining some terms. The first one is harm. Harm is injury or damage to the health of people, property, or the environment. It's the bad thing that happens. Hazard is a source of harm, and we'll have a flowchart in the next slide that walks us through that. Hazard to situation is a circumstance in which people are exposed to hazards, and risk is the effect of the harm. It's a combination of the probability of occurrence of harm and the severity of harm. So it's a measure of how bad the harm is likely to be. So let's look at it as an event chain here. We start with a hazard. Things can sometimes go wrong, and we have hazards. Then in a sequence of events, in certain circumstances, these hazards can create hazardous situations. So these are circumstances in which the patient is exposed to the effect of the hazard. So the hazard could be rain, the sequence of events that I'm driving a car, and now I find myself in a hazard situation, the road is slippery. And that leads to a harm, the effect of a hazard on the patient or caregiver. If I get in an accident, what could possibly happen to me? And the risk from a specific harm is a combination of how likely that harm is, the probability of harm, and the severity of the harm. And risk is high when both of those things are high. It's both likely and severe. It gets to medium as one of those two becomes lower, and then it's low risk when it's either low probability and low severity at the same time. Here's a few more definitions. We'll talk about processes such as risk analysis. It's a systematic use of available information to identify hazards and to estimate the risk. What can go wrong, and how bad is it likely to get? Risk control, these are the processes in which decisions are made and measures implemented by which risks are reduced to or maintained within acceptable levels. So what are the procedures we make sure to minimize the effects of risk? Residual risk is the risk that remains after we've taken measures to minimize it. And then all this fits back into risk management, just to restate it, the systematic application of management policies, procedures, and practices to the task of analyzing, evaluating, controlling, and monitoring the risk. To jump back to the previous document, the QMS guidance from the INDRF, this is back into the section that talks about risk management. It's a very short section, about page and a half, section 7.2. And it has some more advice here that the risk management should be integrated into the entire life cycle, and risk should be considered at all stages: design, implementation, verification, validation, deployment, maintenance, and retirement. And this is what, in fact, we're going to do. Risk management is not a one-off activity, and in the next 5-6 lectures, when we talk about design, implementation, verification, and all of those things, in each of those lectures, at some point, you'll see the slide risk management with the icon on the top left corner. And this is when we ask what could go wrong at each of these phases. So something can go wrong in the design because we design something that can't be implemented or it's a dangerous design. Things can go wrong when we code because we make mistakes. Things can go wrong when we test the code, maybe because we did something bad in the testing. We don't have the right procedures in place to make sure that we catch things that are bad. Things can go wrong in deployment. Our software may not correctly interface with the rest of the infrastructure. Maintenance is a major source of risk if an update breaks the code. And things can even go wrong when we retire the software. If there's valuable data on a computer that's being retired that's not properly transferred out, it could risk to harm to a patient if that computer gets recycled and confidential data is on a hard disk that somebody else could exploit. So we will be revisiting risk management at each step in the process. In fact, this week's segment are just to set up the basic principles, but we'll see it in practice throughout the rest of this class. So here are some principles that the MDRF gives up for risk management. We need to account for both what might happen during normal use of the software, when we use the software as intended, and reasonably foreseeable misuse. Not only do you ask, what could go wrong if our users use our software as needed, but what if they make a mistake? We need to understand the environment in which our software will be used in and the issues that might arise from this. We'll have a checklist in the next slide. And as always, the use of software updating, duplication, distribution creates additional risks that need to be accounted for. Many of you have had the experience that you get an update on your computer on Tuesdays if you're on Windows, because that's when Microsoft releases patches, and all of a sudden your system doesn't work as well anymore. This has the risks involved in software updates. So the MDRF also has a nice list of the categories of hazards. The hazards arise from the user, especially if used at home. If the user is visually impaired, you could get mistakes because they can't read the text properly, or if they have problems with their hands, they may not be able to navigate the user interface. We have risk from the application. The application itself could allow the user to perform something that's harmful, and maybe we need to restrict the availability of the software. The device could introduce a risk. If the screens are too small, you may miss an important piece of information that's off to the side. We may have risk from the environment. We could drop network connectivity. It could be a noisy environment, and you can't hear the appropriate warning sounds. And finally, we could have security risk. If it's connected to the internet, we have to worry about cybersecurity. All of those areas should be examined as potential sources of hazard from the medical software perspective. There are other sources of risk. If you broaden out the lens and look at a business as a whole, we have cost risk. Maybe the software costs more than we can afford. You have technical risk. We failed to develop it. It's too complicated. We have schedule risk. We fall behind time, and a competitor managed to get there before us. We have organizational risk. We don't have the right people in place, or organization just not suited for this kind of development. And finally, we have market risk. We managed to get everything right, and nobody wants to buy our software. We also have regulatory risk. We failed to meet regulatory approval guidelines. And finally, risk management can affect business strategy and the legal situation a company finds itself in. If something goes wrong, we may have to worry about legal fees and insurance premiums goes up. And so risk analysis and management is not just a regulatory exercise. It directly impacts the operational costs and thus the bottom line of a company. And the reputational loss might be much worse than anything else. So if you look up the news headline and it says FDA recalls your product's company name, that could be disastrous for a company in terms of its ability to stay in the market and to generate profits and to create products and things like that. So risk management is an all-encompassing process that affects every aspect of the operation of a company. We always have to ask, what could go wrong here and what can we do to make sure that either it doesn't, or if it does, we control the effects of that thing. With that, we'll jump into a discussion of the actual process for risk management in the next segment. Thank you.